Hey everybody, how we doing? Not too sleepy after lunch? Okay. Thank you, Max. So my name is Chuck, and I'm a mobile engineer at Button. And today we're going to talk about working effectively with Android legacy code. You might be wondering why that one word in my title is in parentheses. And it's really because the principles and the ideas and the concepts we're going to talk about today aren't specific or particular to Android, right? Android isn't the only platform that has legacy code. So we're going to look at kind of these general principles and ideas of software development that we have learned over time in the industry and how we might apply them to specific situations you might encounter in the Android world. So if you're not an Android engineer, don't worry. Hopefully you'll still get something out of this. So it's really great to be here in front of this rather large and intimidating screen. But mostly I'm really excited to see all of you here because when I've given conference talks in the past, well, I guess I'm just not that used to people, that many people finding the topics that I speak about interesting. And so it's kind of surprising to see so many people here. For example, in 2014, I gave a talk at DroidCon New York about working with open source location and mapping frameworks on Android. The big takeaway from this session was most Android developers would rather just use Google Maps. Or fast forward to 2016 when I spoke at DroidCon San Francisco about forks of the operating system and fragmentation and kind of what that meant for the future of the Android ecosystem. This talk was kind of just a 45-minute rant about how Google Mobile Services is kind of against the traditional open source idea of the Android platform. Not really, but kind of. But as you can see from all the empty seats there, basically everybody at the conference agreed with me. No, they actually did. They were just other interesting talks at the same time slot as mine. And then going back a little bit further in time to 2012, one of the first conference talks I ever gave about Android was about test-driven development. And at the time, how many people were doing Android development in 2012? Okay, some of us, good, a good number. So at the time, if you remember, testing was not that hot of a topic in the Android development community at the time. We didn't have very good support for things like unit testing built into the Android framework. You had to kind of jump through some hoops to actually make it work. And so it was around this time that I discovered a little testing framework called Roboelectric, which I became an early user of and contributor to, which might not be as popular today as it was then, but it was a huge step in sort of advancing forward this idea of testing and quality and doing things in a more disciplined way when you, as an approach to Android development. And I should probably mention, too, that almost every talk I've given since this one about Android is really just a Trojan horse to talk about testing more. And today's talk is no exception to that rule. Okay. So before we get into all that, I want to talk a little bit about this idea of legacy. And really, you know, it's not such a bad word in many contexts. When I think of legacy, I think of things like vintage, right? Retro, old school, traditional. These are all nice things that we think about. For example, what about retro video games? This is a picture of Barcade Chelsea in New York, which I enjoy going to, but it's not that different from the arcade that I grew up going to at the mall. Actually, we're at a mall today. At the mall down the street from where I grew up in the States. And so, you know, for me, this idea conjures up a lot of nostalgia. I think Max mentioned in the intro that I do some traditional African drumming as well, and these are actually photographs that my teacher shared with me last time I was there to visit him in Guinea-Conakry. But old photographs have that idea of nostalgia, right? Of vintage that, you know, when they're a little bit yellowed and they start to curl at the edges, that just like kind of conjure up these good, warm, fuzzy feelings. Or what about Magic the Gathering cards? Any folks here who play Magic? Yeah? So there is a group in the Magic community, which I play myself as well, that is so dedicated to this idea of nostalgia and of the legacy of the game that they created a format where you can only use cards that were printed in 1993 and 1994, which is great for those of us who have been playing for a long time like me. Well, thinking a little bit about the history of Android, You know, how many people have like warm feelings when they think about some of the first devices of Android that came out? I actually love this phone. This was the Motorola Droid was my first Android device, and when it came out in November of 2009, it was running the latest and greatest version of the Android platform, Android Eclair 2.0, which was a huge step after Donut as far as user experience is concerned, and also for us as developers. And so this is also around the same time that I started developing for Android, was in 2009. And you know, programming for Android has evolved quite a bit since then, and things are very different now than they used to be. For example, do we get the same warm, nostalgic feelings when we look at something like this? So that's probably too small for you to read, and that's a good thing, because this is very messy code that was written around the same time that I had built a sample app that would work to interact with the contacts API, so the content provider that can get the contact information off the device, and it abstracted away, so there were breaking API changes introduced in Eclair that changed the contract with the contacts API. And so what I did here is I built a sample app that kind of abstracted away the contacts API behind this abstract class where it would load different versions of it depending on what version of the platform you were on. But just the sample app itself, you've got an async task running right inside of your onCreate method. Oh wait, let me get that back up there. Nope. Yeah, so you have an async task running inside of your onCreate method that creates, and so we wanted to be good stewards and not block the loading thread or the UI thread when we were loading the contacts, right? Because this might be a long-running operation. So instead, we just showed a big dialog with a loading spinner on it, so you still couldn't interact with the UI at all. Conventions were very different then, and the way we do things now have evolved quite a bit. So the moral of the story is Android is not new anymore, and all projects that we work on are not greenfield projects. So when we find ourselves in the position of having to work with one of these older code bases, maybe not quite that old, but even something from just a couple years ago, things are changing so rapidly that we can't always use the latest and greatest tools, or maybe we can, but for whatever reason there's other restrictions on the code base that you're working with. Maybe you work on SDK projects and you don't want to make it fat with all these other third-party dependencies that might conflict with your partner's applications. And so sometimes we need to work around not having these things available and do things in a little bit more of a manual way. And so that brings us to the idea of legacy code. And when I was doing research for this talk, one of the oldest definitions I could find for legacy code is just code that someone else has written. So the idea that I'm now the maintainer of this code, right? But I'm not the original author of it. So there's going to be a gap in knowledge there. Well, over time, that has kind of evolved to mean now developers use this more of a slang term, which is code that is difficult to change and that we don't understand. I think most of us can relate to this definition of legacy code. Well, Michael Feathers, in his book from 2005, which was actually the inspiration for this talk, Working Effectively with Legacy Code, offers a different definition, and that is code without tests. Now, the reason I really like this definition is because coming from a testing background and having some experience in seeing the way different projects play out, code without tests becomes harder to change over time. Because when we make a change, we can't necessarily know if the change we're making is going to do the thing that we think it's going to do. Is it going to have any unintended side effects? Especially if you're not the original author. And so to have tests around your code base essentially makes it easier to evolve it, easier to change it. Code without tests becomes harder to change, also harder to reason about, and over time, more error-prone. And so let's talk a little bit about the actual mechanics of what it's like to change software. And so really, there are 4 reasons to change software: adding a feature, fixing a bug, improving the design, or optimization. Now, when we think about the first 2, adding a feature and fixing a bug, these are really similar in the sense that in both situations, the end result is a change in behavior. And let's be honest, a lot of times one person's feature is the next person's bug request. For example, has anyone ever had a product manager come to them and say, oh, there was a bug reported in our app. It doesn't have a save button on the profile screen. Well, no, we just didn't build it yet. That's an enhancement. But anyway, I don't want to get on that tangent. So the first 2 reasons to change software are to actually modify the behavior. When we get into improving the design and optimizing usage of resources, This is more where you actually want to preserve the behavior of the application, but make some kind of changes to improve the way it works under the hood, or maybe improve its maintainability. And the goal here is to not change what you're doing. Well, how are we going to know that we haven't made a change? Are we going to run the app and walk through it manually every time? I mean, I don't know, maybe that sounds like fun to you, but I can think of better things to do with my time. So for me, I would rather have a suite of automated tests that'll let me know that if I wasn't intending on changing the behavior, that nothing has actually changed. And so I really want to zero in on this number 3 here, which is improving the design of your application for the sake of just making it more readable, more understandable, more maintainable. We have a word for that. It's refactoring. And so the definition for refactoring that I like to use is the act of improving design without changing the behavior. This comes from Martin Fowler, who also wrote a book, again, that predates Android itself. So these are not new concepts in software development. And I don't know why I decided to use the British spelling for the word behavior here. I don't know, maybe I thought it looked cool. But we're just going to go with it. And so refactoring is the idea of just improving your code without actually changing the end result. I also really like this quote because this really gets at the reason why refactoring is important. So 2 of the goals when you're refactoring, especially with the purpose of trying to get tests in place around an older code base, would be sensing and separation. And so the goal here with sensing is that if your code is tightly coupled and a tangled mess of dependencies, then it's going to be really hard to actually see what's going on in there. You can only do black box testing unless you are able to sense what is happening under the hood. Similarly, with separation, if we want to test a given class or component or method in isolation, that becomes really hard to do when it's tightly coupled to another piece of the system. And so the idea of separating one from the other is what's going to enable us to then get that more targeted unit testing and sense what's actually going on. So that brings us to the idea of a seam. And a seam is really a place in your software where you can make a change to the behavior without actually editing the code in that place. So kind of a weird thing to think about, right? If I want to change the way this class over here works, probably my first instinct would be to change that class. But in reality, if you can find a seam, maybe where that class is created or how its dependencies are provided, I can change the behavior of this class by making an edit over here. And maybe for one reason or another, that's going to be a little bit safer, a little bit less invasive to the system. And so when we think about applying this to Android, this often means finding the seam between your code, your application, and the framework or the OS. There are different types of seams available. One is pre-processing seams. We don't really have these so much in Java. This would be like pound-defined macros, conditional compilation. The closest thing we can get is with modern compilers. If you have a public static final constant, then that will get compiled out, but it starts to make your production code pretty messy if you're conditionally compiling certain parts of it. So I don't really recommend that approach in most cases. Another option here is linking seams. This would be something like using a custom class loader or adding different dependencies on your class path in your test environment. Again, it's possible, but not always the most straightforward method. Whereas the third type of seam, an object seam, is one that I actually find really useful and the kind we're going to focus on today, which is finding the seams between the different classes, the different components inside your code, and how to separate those. So let's do a quick exercise here, and I hope this is going to be big enough that you can see it. But let's look at an example of an activity here and see if we can find a seam. So I'm going to cheat. I've got a copy of it right down here. So in the onCreate method of this activity, we're doing our typical stuff to set up, and then we're creating an instance of this class called a notification factory, which is just kind of a helper to abstract away the boilerplate that we have to do to show a local notification in the status bar. And so all the notification factory does is it takes a title and it takes a body and it puts those into a status bar notification, and it goes ahead and displays that to the system. Well, what if we wanted to test the way we're interacting with that notification factory? Is there a seam here where we could actually do that? No, right? Because we're using the keyword new and we're creating it right here in line. So there is really no way for us to replace this notification factory with a test double in our test environment. Well, let's look at another example. So now, take the same activity, but instead of creating the notification manager in the onCreate method, we're actually going to use a page out of the playbook for clean architecture. We're going to create a presenter, and we're going to delegate. We're going to tell the presenter, hey, go ahead and display this notification for us. Well, what does the presenter do? It just creates an instance of the notification factory. It displays the notification. So have we actually improved the situation here at all? Not really, right? We still can't get a test, a mock in place instead of that notification factory. And so this version is arguably even worse than what we saw in the first one, because now we have taken our dependency and we've somewhat hidden it away. And then on top of that, we've polluted our presenter with an Android context and other details that we might not want it to know about, to really no benefit to ourselves. Well, now looking at this third example, going back to the activity, we are, now this time when we create the presenter, we're actually going to, in the constructor, give it an instance of the notification factory that we already created here. So we're still using keyword new inside of onCreate, but then we're handing that to the presenter. And then the activity says, you know what, my work is done here. Presenter, figure out how to present this notification. So now we have a seam. We have a way that we can test that we're calling notify with the expected title and body without actually changing the code here inside of the presenter. So that's kind of the idea we're getting at with the concept of a seam, the ability to change the behavior. We could pass in a subclass of notification factory now and get some different behavior out of this class without ever editing main presenter. Similarly, we could pass in a fake one and we could test the behavior of it. So as long as we're doing definitions, I'm going to throw one more at you, and that is the idea of technical debt. You hear, we all hear folks talk about this all the time. And technical debt is really a measure of the amount of refactoring you need to do in order to make a change non-invasively. This definition also comes from Michael Feathers from a conference talk of his in 2014. But the idea here is that all change has risk. And the more invasive your change is, the riskier it's going to be. How can we mitigate that risk? Well, let's take a look at some of the tools we have available to help us evolve our software when working with legacy code. So Android Studio, powered by IntelliJ. I used IntelliJ for Android development a long time before Android Studio came out because the refactoring tools are so good. We have the ability to extract methods, extract classes, rename things. These are all conveniences with modern IDEs that didn't always exist. And I encourage you to rely on them heavily if you're going to make any kind of change, because this makes the chance of making an error is less likely when it's all automated. We also have testing. So on Android, we have three different kinds of tests. We have local JVM tests, unit tests in the JVM. We have instrumentation tests, and then we have UI tests, which are still instrumentation, but they're driven through the UI by Espresso. And so if you're familiar with the testing pyramid, in general, you want to have most of your tests be unit tests, then fewer integration, and then the fewest UI, because as you move up the pyramid, testing becomes more expensive and slower and a little bit more brittle. And also, when you're testing through the UI, you don't always know why something broke. And so what we're really going to focus on today is kind of how we can leverage unit tests primarily as a way to help us evolve a legacy code base. And then finally, when testing, you can also, we mentioned mock objects and fake collaborators and things like that, where you can send in a test double as a dependency so that we can more test things in isolation. Help us with that sensing part of changing software. So what are some strategies that we can start to think about for how to approach this problem? Well, a lot of you, like myself, might have found yourself looking at a legacy code base one day and been like, I don't even know where to start. You know, I don't know what this code does. I don't know how we're going to change it. I don't know how we're going to deliver this feature on time that somebody's asking for. And my suggestion would be to just start where you are. Wherever you need to make a change, that's where you should start focusing your efforts. Not some big overhaul or rewrite or spending a month like, oh, we need to spend a month writing unit tests before we actually make a change. But rather, focus your efforts on what you need to change, why you need to change it, and then build your scaffolding around that. And so I think what you'll find is over time that changes tend to cluster in a system. So like if I edit a file today, there's a good chance I'm more likely to edit that file again than some other one that hasn't been touched in 2 years. And so if you start building your test suite around the parts of your code that change most often, arguably that's where you need them the most. And then one other thing I want to mention as we get into the details here is that sometimes when you approach this type of project, your code is actually going to get worse before it gets better. If you have any sense about like what good software design looks like, we're probably going to break all those rules today. But it's going to be towards the goal of enabling us to evolve the code over time, which is then going to get us to a better place in the end. So the first technique or strategy we're going to look at here is sprouting a new method. And the idea here is simple. If you're going to make a change, rather than editing code that already exists, it's usually going to be safer to isolate your code into a new method. And so an example from the Android world is, say I have this idea of some analytics tracker where I want to send events off to my server to track user behavior so that we can optimize the flow. And so the event tracker class just does a few simple things. It takes a list of events, and then it sends them off to the API. The hidden dependency here is that calling event.track does generate an HTTP request in the background. Okay, one thing worth pointing out. Secondly, our event tracker also wants to keep a local cache of events that we've seen. And so when we do that, let's say we're taking a shortcut and we're just serializing it and sticking it into shared prefs. Again, not ideal, but we're not here to talk about perfect. We're here to talk about practical. And so if we have a new requirement that now with the event tracker, we want to avoid reporting duplicate events. If the user clicks the same button over and over, we only want to report that interaction one time. And so one way we could approach this is by actually editing it right there in place. We can, inside of the track events loop, we can put a check in place that says, okay, let me get the list out of shared prefs and see if this event's there. If it's not, then I'll report it to the API. If it is, I'll do nothing. And then eventually add keep track of which ones were unique and add those into shared prefs. Well, this will probably get the job done, but this change is also extremely invasive in that you're starting to edit a lot of pre-existing code that might not have been tested and you don't know if you're breaking it. So another approach here is we can add a new method to the event tracker, which has the one responsibility of figuring out if a list of events contains any duplicates. And then what we can do is, when it comes time to deduplicate the list of events that we're getting in here, we just simply add one line, which is a call to that new method, unique events. And this way, we've actually separated our changes from the existing code and done it in a less invasive way that we actually have reduced the risk of the change that we're making. Okay. So just to summarize real quick, sprout method, you want to identify where you're going to make the code change, and then create a new method that does the work required. Whatever local variables that change was going to interact with become arguments to that new method, and then you can write tests for your new code, and you don't have to worry less about breaking existing code that was already there. More importantly, if this is a long and complicated method, you don't have to write tests for every single code path in that method. You can focus on testing the new code that you've added in isolation. So similarly, instead of sprouting a new method, we can actually, if there's enough complexity required, we can sprout an entire new class. And so here's another long code sample that you're not going to be able to read, but just judging by the amount of indentation that's up there, you can imagine that there is a lot of nesting going on. There's a lot of code paths here that are going to be hard to test, and that is basically one big black box. The TLDR on this sample is that this is a login activity where it takes a username and a password that the user has entered, and then when they click the login button, it does some input validation on the text in those fields. If it passes client-side validation, ships it off to the server, waits for a response. If we get back success from the server, we proceed on to the next activity in the flow, and if it comes back as invalid credentials, then we display an error message. So now, let's say we have the requirement that we want to actually add a forgot password button to this screen in the app. So how are we going to do that? Well, we could do it in the same way and just have a find view by ID in our onCreate. By the way, I know this is verbose, but I decided to use Java instead of Kotlin for all my code samples because I wanted us to have a more authentic legacy code experience. And so when it comes time to add the forgot password button, we're going to sprout a new class to do that. We're going to create a presenter, and we're going to delegate. Now, this doesn't mean we have to move all of our existing logic for the username and password and the actual login, the API. We can deal with all that later. But right now, if the goal is to deliver at the end of this sprint a forgot password button, let's just think about that. Let's create a new class, delegate the responsibility of hitting a different endpoint in our API, and let's pass the dependencies in through the constructor. And then at this point, testing that new functionality becomes trivial. And so when you call it from the activity, our code is much cleaner, way less nesting, way less confusion. So sprout class, identify where you need to make the change, write a new class that's going to do the work that you need. Any local data that you would need to interact with, local variables, they become arguments to the constructor or the public method on the new class. And then you can write tests for your sprouted class. This next strategy is what I like to call the tasty burrito refactoring approach, or otherwise known as wrap class. And so going back to our example of the notification factory, let's say that we have so here's a peek inside of how that class looks. So we have one method called notify. I think I added a pending intent here. So now we pass it a title, a body, and a pending intent to be shown in the notification. And let's say we have a new requirement here that we want to integrate our notification factory with our event manager so that when we show a notification, we actually report that event to our server as well. So again, we want to avoid making invasive changes inline. So we're actually going to take this class and turn it into an interface. We're going to pull out an interface, call it the same thing, and have the same signature on all the methods, but then rip out the implementation and move that into a concrete class that implements the interface called simple notification factory. Again, your internals here have not changed one bit. All we did was rename the class and add an interface. Now, when we want to add the event tracking behavior, we can create a different concrete implementation of notification factory. We're not going to subclass the simple notification factory. We're just going to implement the interface. But then what we're actually going to do here is pass in another notification factory to the constructor. Seems a little bit weird, right? This is actually a classic pattern from software development called the decorator pattern. And so our tracking notification factory actually decorates the original simple notification factory, where we can now, when the notify method is called, add the new behavior there, and then just delegate the original behavior to the original class. Again, non-invasive, and we can write tests for this one, and we can get around to writing tests for the other one once our product roadmap has slowed down a little bit. So when you're wrapping a class, you want to identify the method where you need to make a change, build a class that accepts the old class in the constructor. Oftentimes, the easiest way to do this is by extracting out an interface. And then you want to create a new class, or rather, when you implement that same method on the new class, that's where you add the new behavior, and then you delegate to the old class for the original behavior. So now, there's many more strategies we could talk about like this. Some of my favorites are you can wrap methods similar to wrapping class. You can sketch out the different effects of how the pieces of your application interact with each other. That helps you find things like inception points and pinch points, which is just fancy terminology for where the code changes most often or where a lot of different paths all converge. And so you kind of want to focus your testing on those points. And finally, my last point of advice on this topic is just, if you see dead code, delete it. That's why we have version control. Don't make the next engineer who reads that file read the same code and try to figure out what it's doing if it's not actually getting run anymore. So now I want to talk really quickly about dependency breaking techniques. And the idea here is sometimes it's really hard to make a change in behavior or even just do a pure refactor. It's hard to get tests in place before we do that. Sometimes we actually have to start refactoring before we can even write our first test. And so a dependency breaking technique is a way to safely do that minor refactor that's going to allow you to get tests in place that then will allow you to make more comprehensive changes. And so let's look at an example of another presenter we have here, which is somebody was on the right track here. They wanted to start layering the architecture, but maybe there's still some issues that need to get ironed out here. So we have a presenter for our user activity, which when the profile button gets clicked, loads the data that we have for that particular user stored locally on a database. And so it's good that we already have a presenter that's decoupled from our activity in the Android lifecycle. So that's a step in the right direction. But the challenge here is that our presenter is still dependent on this database manager and on a context. And even worse is the database manager is a singleton, which presents some unique challenges when we're talking about how to get it into a test harness. So what we could do is write a bunch of instrumentation or espresso tests to drive this thing through the UI, but that would require pre-populating our SQLite database with some expected values and then compiling and running on a device. And this all takes time. Really what we'd like to do is find a way that we can unit test this particular behavior before we start making significant changes to it. And so one way to do that would be by parameterizing our click handler method. So we can pass the database manager in as an argument to on profile button click. Again, we're doing this before we have any tests in place. But if we do just this minor change, then that can actually help us get into a better position where we can then write unit tests for this class. So if you want to parameterize a method, you want to make a copy of the original method that you want to do. So notice actually here in this example that I left in the original signature there of on profile button click. We made a copy of it that adds the new behavior. Maybe there's different parts of your application that use the same class. You don't want to necessarily have to convert them all right now before you get tests in place. So we're going to make a copy of it. We're going to overload the method and create a new version that allows us to make it a little bit more decoupled. And so the goal here is that we copy the method that we had. We take something that was being created or accessed internally and move that into the as a parameter to the signature. And then you can delete the body of the original method call and make it delegate to the other one. Another way to do this is passing your dependencies through the constructor. This is a version of dependency injection. We have fancy frameworks that do this. There's also a manual way to do it, which is just pass it into the constructor of your object. So now in this version, we've created a second constructor for the user presenter where we pass in that instance of database manager, so we're not accessing the singleton directly. But we kept the original one around as convenience, and so that we didn't break our code in a bunch of places if the old one is still being used. We only want to make this change where we actually have to change the behavior right now. And so this gives us another way to get in a fake collaborator in our test environment and make things a little bit more decoupled. So same idea, we're making a copy of the constructor, we're delegating to the original one, and we're introducing a new parameter. Because we're dealing with a singleton here, though, we have one other approach that is available to us, and that is we can actually attack the singleton dependency at the source where it's created. We can introduce a static setter method onto our singleton. Now, you might be freaking out like, oh, you can't actually, edit a singleton. There should only be one instance ever. So again, this is a technique where sometimes things need to get a little bit worse before they get better. Once we get tests in place, then we can do more substantial refactoring, which would maybe even allow us to get rid of the singleton altogether and have this be just a regular old class that we create when we need an instance of it. But for now, we're dealing with what we're dealing with. And so here in the database manager class, we can see that it has one primary method here, which is to fetch the user. It takes a context. It uses that to build up its access to the SQLite database. I'll spare you the details there of how that works. But the problem is once that the database manager's constructor is private, and once that instance is created, there's no way for us to change it. And so what we can do is actually relax the scope on the constructor, make it so that we can build a test version of this class, and then add a setter that will actually allow us to replace it in the test environment. So introducing a static setter, again, these are not ideal design principles, but these are some of the practical trade-offs we want to make when we're dealing with an older system. So you can decrease the protection on the constructor from private to protected. Then that will allow you to subclass and override any behavior you don't want running in your unit test environment. For example, accessing a database. You can make the static instance mutable by removing the keyword final, and then add a test-only setter, and we have this nice annotation visible for testing, which I'm always nervous when I tell people about it, and you've probably seen it before, but it's like you don't want to overuse it, but in some instances, I didn't even mean to do that. In some instances, in some cases, you actually want to relax those principles a little bit so that you can get your testing in place. So there's lots more techniques. Again, I encourage you to get the book that you can use for breaking dependencies. And if you follow the simple set of steps, these are refactors that you can start to make without tests, with the goal of then getting tests in place, which will allow you to make more comprehensive changes over time with less risk. So I just want to leave you with a couple final thoughts. We're running out of time here, and so let's wrap it up with, before you get into making any sort of like large-scale refactor or evolution of a legacy code base, you really want to think about what your motivation is. What am I trying to do here? Am I fixing a bug? Am I introducing a new feature? Are we consuming too much of the battery life on the device? What is the goal here? Once you decide what the goal is, really zero in on that and really only make changes related to that. When you're dealing with legacy code, you might see changes, you might see things all over the place. And you're like, oh, I want to fix this, and I want to clean this up, and oh, I can cut the code in half in this class if I just do it a slightly different way. But once you start making that level of change, then you're introducing a lot more risk than might have been originally necessary. Rely on your refactoring tools. Rely on your teammates. Another valuable tool here is pair programming. Getting a second set of eyes on a change you're about to make that's not covered by tests can be invaluable. And then finally, start getting those tests in place. I told you all my talks were Trojan horse to talk about testing. I'll leave you with this one final thought, but as developers, as engineers, really, we just want to take care of the code that we have to work in every day, because if it's not enjoyable to work with, really the person we're hurting the most is ourselves. So think about that next time you need to go in and edit a file, and on that note, I'll just say thank you.